What's up, everyone? Today we're talking about derivative graphs. Now, before we actually take a look at the notes, here's a little chart that might help you out if you get confused, because it's easy to get confused between these three things. All right, so here's my original function, my first derivative, my second derivative, right? And here's a chart. The way that you make this is pretty simple. It's just plus or minus, plus or minus, plus or minus, increasing, decreasing, increasing, decreasing, and then concavity here. So what this is telling me is that when my first derivative is positive, my original function is increasing. When it's negative, it's decreasing. Okay, and when my first derivative is increasing, that means I'm concave up. When it's decreasing, I'm concave down. All right, and then same thing here. So when my second derivative is positive, my first derivative is increasing, and my original function is concave up. When my second derivative is negative, my first derivative is decreasing, and my original function is concave down. All right, so here's all the information that you'll probably need. All right, so let's take a look at our notes. Okay, so we're given a graph, and this is the derivative graph. Okay, so you got to make that real clear to yourself. I'm going to write it a couple times. Okay, this is my first derivative graph. It's not the original function. And so for the first question, they're asking me when a graph of f is increasing. So when the graph of my original function is increasing. Now remember, your graph is increasing when your first derivative is positive. Right, so I'm just looking for intervals where I'm positive, so -3 to -2, and then 0 to 3, I guess. All right, so that's where we're positive. Now, if you put 0 to 2 and then 2 to 3, that wouldn't be wrong either. That'd be fine. Okay, and my justification would be because f prime is greater than 0. All right, so remember, when you're justifying, you always want to justify with the information that you're given. We're not given the graph of f, and we're not given the graph of f double prime. We're given the graph of f prime, so we need to justify in terms of f prime. Okay, for part B, it asks when we have a relative maximum. Okay, so I know I have a maximum. When my first derivative changes from positive to negative. Okay, so I'm just looking for where it changes from positive to negative, so it looks like here, and then it doesn't change anywhere else. All right, so looks like at -2. So, f has a relative max at x equals -2. We could say because f prime changes from positive to negative. All right, and that would be my justification. Okay, next it's asking me when the graph of f is concave down. Okay, so our concavity in terms of the first derivative has to do with whether I'm increasing or decreasing. Right, so concave down means I want my first derivative to be decreasing. All right, so I'm looking for f prime to be decreasing. It looks like it's decreasing from about here to -1. It's increasing and then decreasing from 1 to 2. Okay, so -3 to -1, and then 1 to 2. Alright, so I can say from -3 to -1, and then 1 to 2, and my justification would be because f prime is decreasing. Alright, so again, my justification is in terms of f prime. Alright, next one. They ask me when the graph of f has an inflection point. Okay, so that's going to be when f prime changes from increasing to decreasing or decreasing to increasing. Okay, so that's what I'm going to be looking for here. Essentially, I'm going to be looking for extrema on my first derivative graph. All right, so it looks like I have a point here, looks like I have a point here, and it looks like I have a point here. All right, so it changes from decreasing to increasing at -1. changes from increasing to decreasing at 1, and then changes from decreasing to increasing at 2. Right, so -1, 1, and 2. So I can say x equals -1, 1, and 2, because f prime changed from increasing to decreasing and decreasing to increasing. Okay, in this last example we're going to do is a warm-up tomorrow, so I will see y'all later.